Hey, so hi everyone. My name is Britta Sheck, like Patricia just introduced. And today, together with my colleague Matthias Baron, we will provide a proper introduction to Altair Pulse. Through a few demos, we are hoping to give you a very good understanding of what the purpose of Pulse is, what type of use cases it can be leveraged for, but also how to actually start working with it yourself. But let us start with a short introduction. So the main purpose of Pulse is to aid the orchestration of meaningful models across different platforms. There are two main use cases. The first is to orchestrate and build processes, which enables streamlining of workflows by building cross-application solution and processes. And with that, we are also supporting multiple programming languages as they come along with each application. It can also be used as an engineering project platform, which allows you to be an engineer, execute a process and explore and compare and evaluate design and results, really focusing on solving the real world problems, which we know are rarely limited to one physics at a time. So when looking at Pulse, you could separate it into three components. We have the automation scripts, which is the heart of any automation. We have the communication between the different applications. And important here is that this is not limited to Altair applications, but also a third party. Both components are packed into a very intuitive user interface, which makes it easy to string processes together using a modular approach. So with this, let's dive straight in. And here I'll hand it over to Matthias, who will guide you through the product through a few demos.
Perfect. So thanks, Britta, and hello, everyone. Thanks for attending this very exciting Pulse GTA. So in this first demo, we will take the role as an analyst and execute a ready-to-go Pulse project. So the process here represents a very common simulation workflow that creates a report containing mode shapes for any selected geometry. So in this demo, you will see that it's an end-to-end process where the only user interaction will be to set up parameters like the geometry file, the element size, and the number of modes. And we will end with a full result report. So let's go ahead. Okay, so we will start by opening the project through the File tab, and then we will update the project parameters. We will call our project normal modes. A project can consist of multiple studies. In this case, we will use this one to analyze an airplane hull. Once we execute the process, the necessary input will be asked to the analyst. We can keep track of the data flow and specified KPIs throughout the process in the variable browser. For example, you can see the selected file path and the mass value updating accordingly. The end-to-end process is now finished. And now, in just under a minute, we have generated a report containing all modes for the selected geometry. Now, let's create a new study with the exact same workflow, but to evaluate a completely different geometry. A beam will be analyzed this time. When we execute the process, the user will be prompted for the same parameters, but we are going to do something different this time. We're gonna press pause. When the process is paused, the progress and all simulation data generated up until this point is stored, even if project is saved. This enables the analyst to start from where he left off any time or day, or even share it with a colleague, making Pulse a collaborative tool. And in the similar way, we can review the report now with the new geometry. Okay, so I have now demonstrated how an analyst can easily execute and interact with a process, and put main focus on solving the engineering problem at hand by controlling and tracking variables and KPIs, as well as performing design iterations. Suppose there is a new request from the design team. They want to evaluate the impact on the positioning of the ribs have on the performance of the hull. So in this demo, we will take the role of an author and show how, by creating a new task and adding it to the current process, we can achieve just that. Okay, we will start by creating a new task from scratch, which will take care of the modification of the geometry. We already have access to an automation script. This automation imports a geometry, updates the positioning of the ribs on the hull, and exports a new file. The application the script is created for is Inspire. We will also add a descriptive image which will be displayed on the task, and input the arguments needed to be passed to Inspire at its execution. Then we will select the pre-created automation Python script. Okay, so instead of having the geometry file path hard-coded in the script, we want the user to be able to select it in the process. This is achieved by adding a variable to the task, which then can be referenced in the automation script. The GUI description determines how the user will be prompted for input, this time through a file selection menu. And in a similar way, we can create a variable to control the output for the modified file which is exported. Finally, we create one last variable to control the rib positioning, giving the user multiple options to choose from. We can preview the GUI we just defined. Then we need to ensure that the variables are assigned to correct input and correct output ports. We need to make one last change, as we now want to control certain parameters in the script through variables. To achieve this, we need to update the script accordingly. We will replace the hard-coded values with Pulse Query APIs. Here, I'm showing how we are replacing the file path with the value of input jump variable. The same was done with other variables, as you can see on line 27. We also need to save the changes of the script. Now let's execute the task, and you will see how the hull is modified by Inspire, leaving only the vertical ribs. The successful realization of the task means the output geometry file was indeed created. As the next step, we can now export the task into the library so it can be available to use in the future. Okay, we are going now to create a new session to hook up the previous model workflow with the task we just created. As we are now on the author profile, we can access the predefined process and task through the library. You just saw we created a task that works on its own, but due to Pulse modular capability, we can integrate it into the normal modes workflow. What we will do is take the value of the output of the meshing task and assign it to the input of the geometry modification task. In other words, the meshing to the task geometry input will now take its value from the geometry modification output. When the process is executed, we can see how everything in the workflow works as expected. Note how the meshing to the task will no longer be asking for a geometry input. Suppose that another request from the design team is to update the subtitle on the report. We can do that by pausing the process on the Create Report task and updating the script. This gives the author the possibility to edit or debug a process. We just need to save the script, and then we can continue the execution without restarting the whole process. And we have showcased how to build a task by reusing existing scripts, and with that, also how actually build your own library of models. While building the task, I have shown you two options on how to let the user interact with the process. One is building the user interface through a GUI builder, and the other is letting the user interact freely with the application. And at last, I have shown how an author can save time by debugging or editing the script without the need to lose progress or restart the process. Well, thanks everyone for listening, and I get back to you, Brita.
Thank you, Matthias. So Matthias has now shown the concept of building a modular process. And this can, of course, be expanded to other use cases and applied to solve any type of problem as well. So we started here in this demo to provide a very common, but an example, like a simple example, which I think that everyone can relate to. But this one on its own can, of course, be advanced and adapted much further depending on the needs. So I'll give you a couple of examples. The geometry task, for example, in this case, in Matthias' example, we were using Inspire. But we can easily be replaced by an interactive task where the geometry is being modified manually, maybe, in a third-party application like CATIA. Or we can automate it further and instead actually control all of the CAD parameters through an Excel sheet. And for more heavy geometries or heavy load cases, we can also easily switch the run analysis module that we had in OptiStruct. We can switch it to make sure that we are executing the solver on an HPC instead. Again, all using a modular approach. Or why not just mature the process even further and make sure that we actually include all of the necessary load cases that we need to run in order to evaluate this product. You don't have to do one at a time. And one can also include a condition workflow, as in the example to the left here, where we can make sure that we're using the right model making sure that we're using the right model at the right time with one of these model fidelity switches. And as mentioned earlier, Pulse really allows for streamlining workflows to solve real world problems and not limited to one physics at a time. So in the shown example to the right, we can use modular approach to run a high frequency solution, either on its own, or it can be coupled together with a thermomechanical solution for a multiphysics simulation. Another example of coupled simulations is manufacturing solutions. We can, for example, perform a costing simulation for cooling channels, and then we can verify the structural and fluid performance of them. So I hope this gave you a good idea of the wide variety of use cases that we have. And as a last comment before we close this short introduction, I will ask you to start thinking about what simulation use case or workflow would you, your colleagues, or even customers benefit from if it was streamlined into a Pulse solution like we've shown today. And I am truly confident that there are many. Thank you all so much for listening.